Good afternoon, everyone. I hope everyone had an enriching first technical session. It is now time to begin the second technical session of day 4 of our 6-day faculty development program. And that is on sustainable, cost-effective and eco-friendly solutions for roads, railways, slopes and mining applications using Nano Composite Jute Textile reinforcement. Today's session is particularly significant because sustainable development is not only about producing clean energy but also about protecting our environment. To guide us through this important area, we are privileged to have with us an eminent academician, researcher and internationally recognized expert. So it's my great pleasure and privilege to introduce our esteemed speaker, Dr. Supriya Pal. Dr. Pal is currently serving as an associate professor in Department of Civil Engineering at National Institute of Technology, Durgapur. He possesses over 20 years of combined teaching, research and industrial experience in the fields of geotechnical and geoenvironmental engineering. He completed his PhD in civil engineering and Masters of Civil Engineering with specializations in soil mechanics and foundation engineering from Durgapur University, after earning his bachelor in civil engineering from Nottingham University. Before joining academia, Dr. Pal gained valuable professional experience as a geotechnical engineer, research assistant and Central Water and Power Research Station. His research interests include geotechnical engineering, geoenvironmental engineering, industrial waste product treatment, contaminated land remediation, solute transport through porous media, etc. His scholarly contributions are equally impressive. He has authored more than 35 research papers in SCI, Scopus and Web of Science Index journals. Before we begin today's technical session, it is our privilege to honor our distinguished speaker. May I now request our respected principal, sir, Dr. Ojit Kumar Banerjee, to kindly come forward and felicitate our esteemed resource person. May I request everyone? Thank you, sir. Without taking any more of your valuable time, I most respectfully invite our esteemed resource person, Dr. Supriya Pal, to deliver his expert lecture. Sir, the stage is all yours.
First of all, I would like to thank the organizing committee, basically our student, Ajit Banerjee, Dr. Ajit Banerjee, and all the organizing committee members. And thank you for inviting me in this AICTE FDP, ATAL FDP 2026. So, already Professor has given my introduction. I want to add a little more and I want to just revise. I am now Professor and HOD in the Department of Civil Engineering in NIT Durgapur. You know, Civil Engineering Department, Dr. Ajit knows better. And those who are with you, I can see he is also registered in NSHM. Sonokani. BCI. And others also. He also did his PhD from NIT Durgapur. So we are receiving a lot of funds nowadays. Basically all NITs and IITs are receiving funds. And our civil engineering department is also enriched with lot of funds from ministry, industry. We do lot of consultancy projects. different industries, DVC also, DVC under Raghunathpur, FDP Cell, other NIT and other. This presentation is based on the outcome of different projects sponsored by ministry. There is funding agencies, National Jute Board under Ministry of Textile and National Technical Textile Missions. We have received funds from NIT, National Rural Infrastructure Development Agency under Ministry of Rural Development. We are also acting as STA, State Technical Agency for PMGSI roads for 4 districts like Purba Bardhaman, Paschim Bardhaman, Bankura and Purulia, as well as Andaman Nicobar Island. So this technology that we have developed, actually Ministry of Textile requested us to take this project. They have given a very good amount of fund, more than 12 crores for development of technology that can be used in different civil infrastructures, and it should be sustainable, and we should not depend on the natural resources. We should reduce our dependency on natural resources. That all of us we know, even across different disciplines also, we know the road construction. There are different layers from subbase, base course, then bituminous layers. So in case of road construction, you may have seen that base course and subbase course require a lot of attention, apart from subgrade, because this course requires a lot of natural resources, like aggregates, which should be mined from different areas where it is available, and it should be transported to this location. So huge cost involvement. Nowadays, if you travel through NHI, you will find a lot of dumpers, trucks are flying over NHI, loaded with sand, loaded with aggregates, stones. Now, there is a lot of carbon emissions, transportation cost, and now day by day it is increasing the price. 2 days before I read one news news comes in mobiles also nowadays. You will find that state of Karnataka is banning the transportation or utilizing of natural resources, because cost is increasing and the resources is decreasing day by day. So ministry are now forcing to utilize recycled materials, other materials which can be used as an alternative to the natural resources. So this is basically the project sponsored by, I told, National Jute Board and NTTM, Ministry of Textile. Now you see, in case of road construction, you may find that lot of potholes, lot of cracking in the road surface, elevator cracking, fatigue cracking. So the causes of this distress in roads basically due to the main culprit is water. If you do not provide proper drainage system in the road, then these potholes, crackings will be developed. Again, I can take one example. I am involved in one consultancy project of Military Engineering Services in Panagar. where the runway, they are facing a big problem in their runway. Imagine is involved. In some patches, water is oozing out to the surface. During rainy season, these problems occur more. The root cause of this problem, because this is a very sensitive issue, because if water is coming to the surface of runway, then there is any accident may occur, and this is a very sensitive this airport, Panagara. So they came to me. We are still doing some root cause analysis of the oozing out of water. Similar problem happened in NHI. You may find some places that potholes, crackings are occurring. One company here, they are involved here, the project of water road, Eagle Infra. They also came to us that we are facing some problem. We are visited, and said, I am not being sorry. I am witnessing that there is also a similar problem. The water is coming on the surface. And then water is coming, the water is the main culprit. It causes the stripping of bitumen with aggregate, then cracking happens, then with repeated loading, potholes generated over the surface. Okay. This is the problem. Even rod depth you will find. Along the wheel path, you will find the depression, longitudinal depression over the surface. This is another problem of drainage as well as subgrade failure. So, what may be the solution? We have to provide a proper drainage system below that layer, top layer. This is one, so the water can be drained out. And another is subgrade to be strengthened. Subgrade is to be strengthened. How we can do? Because in this area, apart from Purulia and Bankura, you may find. Okay. So, subgrade may be strengthened. How? Apart from Bardhaman, some part of Bankura, some part Medinipur, even I have seen Andaman Nicobar Island also. We did some testing that subgrade severe value is very California bearing basis. So, those who are from civil background, they can understand. Subgrade severe value is very low, around 1 to 3%. So, if you have the subgrade severe value of 1 to 3%, you cannot expect that the road will be sustainable. Another problem is that we design the road with a traffic balloon. Traffic survey is carried out. Axle load survey nowadays is carried out. ATCC is there. Automatic traffic counter and classifiers are there. Everything is there. But still, you will find that overloaded vehicle is flying over the road. That is not considered. Sand from the Padam and Balighat, they are taking the sand and flying over. That is not considered in design. Overloading is not considered in our design. Okay. So, if we consider VDF of 3, 4 VDF, vehicle damage factor, actually, if we consider the overloading factor, then VDF will be 12. So, we have designed the road under traffic category, say 0.3 MSA or 0.5, 4 MSA for rural road, for NH and PWD roads maybe of 12 MSA, 15 MSA, but actual traffic will be 1.5 to or 2 times more. Road has not been designed, the cross thickness has not been designed based on that traffic category. Okay. So that is the main cause of early failure of road. You may find that most of the roads in rural roads and before DLP, defect liability road, it damages. Okay. So solution is that for this case, we can provide a geotextile. we can provide a geotextile. Geotextile means nowadays, synthetic geotextiles are available. There is PP based, polypropylene based, polyethylene based, okay, polystyrene based geotextiles are available. That is laid over the road. Maybe geogrid, geotextile, maybe of geocells that can be used. And the main function of this thing, it disperses the load into wider area. Load divided by area, that is pressure reduces. Wider area means less pressure. Okay. So substrate will not feel more pressure. Okay, load will be sustained. Another problem. This geotextile, synthetic based geotextile, is a durable material. Synthetic material, more strength, 200, 300 kN per meter in strength. But the problem is that if it is made of FDP, low density polyethylene, then it degrades and it generates microplastic. And this microplastic migrates through this soil and comes to the groundwater, and through root water uptake of plants, it ultimately comes to the human body. And you will find it is reported in newspaper that human body, human blood contain microplastic, human brain contain microplastics. So, and it has been reported that this technical textile is the main source of microplastic, because nowadays huge amount of this technical textile, RE wall, reinforced earth wall, in which you will find all the approach roads for the BOP or DOP made of RE walls. Okay, that is the main cause of it. It is, I am not saying, it is already reported in geosynthetic news article. You will find that there reportedly it is said that this is the main cause of concern of using synthetic geotextiles. Another problem, some researchers in Australia, they have found that it releases the PFAS. PFAS means polyfluoroalkyl substance. It is, you can search in Google, you will find that PFAS, polyfluoroalkyl substance, it is called forever chemical. And the thing is that it doesn't degrade, and it is the cause of the main problem of causing cancer. So, European countries, Australia, they are nowadays telling limited use of these geotextiles. But in here, at third world country, we are using geotextiles for all civilizing bodies. So that's why ministry came to us and they have given the fund so that we can do some research how we can promote the utilization of natural fiber in place of synthetic material. Okay, natural fiber is having good strength, tensile strength, good tensile strength. But the main problem of natural fiber is that it is a biodegradable material. Quickly degrades. You can see we have used natural fiber based on jute based natural fiber from jute plants. The scientific name is something, forgot something. Reinforced earth wall. All the wall you will find. Now you will see here. This is the fiber. Now this fiber, it is contains cellulose, hemicellulose, 80%, 60 and 70%. Cellulose and hemicellulose. Okay. This cellulose, hemicellulose is giving the strength of the fiber. And the skin is made of lignin and pectin. This lignin basically is the food of microorganisms. Under moist environment, they consume this lignin. This is the skin, and the skin breaks out. Then the cellulose, semicellulose, it comes out of this fiber and it degrades completely. So it happens within 3 months because other, I have said before starting this research that even Ministry of Textile, they are some agency, they are claiming that it is it can last for more than 1 year. But I have seen, and as we did the practical field trial also, we have seen within 3 months it completely degrades. It loses its strength. The main efficacy of utilizing this has been out. So what we did, we use some nano composite solution that we have developed at NIT Durgapur. Nano composite solution, with me we have professors from Chemical Engineering Department, Professor Mandal and Dr. Rajiv Ghosh. Okay. So in this point. So this nano composite solution basically you can see here. This basically gives the strength, and this nano composite solution generally it is made of one non-toxic polymer, water soluble non-toxic polymer that we have used some binder material, as well as we have used nano material, okay, mainly silicon dioxide for this particular project. Now this you can see there is a, after using this nano material through deep coating and drying, the tensile strength increases up to 67% of natural fiber. 67% there is an increment of strength. And another important thing, this material you can see here, this material is hydrophilic material. It absorbs water. You can see from the surface, you can see from picture, it absorbs water. But after giving this nanocomposite solution over this material, it becomes super hydrophobic. So there is a term is used, it's called contact angle. So this material, before application of this solution, the contact angle we have checked at NIT Durgapur with goniometer instrument. Its contact angle comes out as 67 degree. But after utilizing this thing, this contact angle, we have found that around 126 degree. Huge increment of enhancement of contact angle, and as contact angle increases, it becomes super hydrophobic. So the advantage is that now you can see, if you check with the water, it will not absorb by the fiber. It passes through, its pore space increases. Water drains out from the material, but it is not absorbed. So advantage is that the microorganism cannot develop. They cannot degrade this material. And during field trial, we have seen more than 2 years, which was earlier degrades in 3 months, it can sustain more than 2 years. So it becomes a sustainable material with enhanced strength, with enhanced contact angle, hydrophobic, as well as the drappability is called drappability. That is a term. If we lay over the undulated surface, the fiber material can take its shape, undulated surface. This material also takes its shapes, only there is a little bit of stiffness is there due to coating. Okay, so that we have done, and then other testing has been done. I am not coming to that. You can see the soak severe value, if you utilize this material over this upgrade, soak severe value increases up to 88%, and there is a reduction in base course thickness of 35%. So when the possible layer, the base course, jute based, due to its enhanced strength, tensile strength, the base course thickness, severe value increases, you can reduce the thickness. Base course thickness reduces by 35%, and it has been found that there is a 18% reduction in cost. So if we per kilometer cost for a rural road is around say 70 lakhs, if we consider, so 18% is around, it's not 18%, I am considering there is no damages in the surface for next 5 years after laying. Okay. These are the things already I told. There is a increase of strength around 67%. You can see basic direction and cross direction of the nano composite material. Draftability, there is a slight increase in draftability of say 10%. Apparent opening size. So its opening size increases because this material after coating, it is passed through rollers with pressure in industrial scale. And during the passing through roller, the pore space increases. The coating reduces the basically the strength, some strength that is due to coating, and increases the pore space. So apparent opening size, you can see that there is an increment of apparent opening size. Permeability also, as opening size increases, so drainage, there will be no problem of drainage, the water can pass through this material. Okay? So it can be easily utilized in roads. This biodegradation study has been carried out at NIT Durgapur. Here you can see in biodegradation, here as I told that the normal material, jute-based material, there is after 3 months of full saturated in soil, there is a strain residual strain around 70%. Yes, 70%. After 6 months of complete submergence, the strain becomes 0. This normal material. Where this material, after 3 months of submergence in water, mimicking the same condition as field, this test has been carried out here. Same condition has been maintained as field. For 6 months of water submergence, there is a residual strength after 6 months. Where it is 0, it is only 6%, 10% you can see there is a loss of strength. So after 6 months means complete submergence. In case of in India, we have monsoon season of say 2 months, monsoon period, 2 months. So 6 months means you can consider 3 years. Okay, complete. But there is a intermittent rain. I am considering there is a continuous rain for 2 months, then it is 3 months it can sustain, 3 years, no loss of strength, 10% only. Okay. But all are laboratory-based study. These are the things, very typical civil engineering things. So the soil has been collected from Purvastali in Purva Bardhaman division, where the severe value was set as 3.05% here, severe value. There is some swelling also, little bit of black cotton nature of soil. That's it. Now, this both the material, normal as well as coating material, that has been, both the material has been tested with different depth in severe mold. Z by D ratio you can see. D is the plunger width around 150 millimeter. That you know about the plunger, severe plunger, loading plunger. And Z by D ratio, normalized scale 0.4, 0.8, 0.2, that has been considered, and it has been found that 0.4 Z by D ratio, there is a maximum increment of severe from 3.05 to 5.7 using our material, and normal material, that is 48% increase. Now, as per the rural road, as per the codal provision IRCSP 72, that minimum severe value, soak severe value should be 5%. Subgrade soak severe value should be 5%. So 3.05 means we have to use some additional layers. So there will be more cost. So in our case, we have got the severe value more than 5%. Then the layer has been finalized. So these are the different layers that you can see. This numerical modeling has been done to find out the strain at deeper in depth and the subgrade as well as just below the bituminous layer. So straight with this reduction, you can see there are three sections has been considered. One is without any reinforcement, another is with normal reinforcement, that is normal material, another one is our developed material. Now all these cases, here the total thickness requirement based on the codal provision as per IRC SP 72, the total thickness requirement is 495 millimeter above the subgrade. 495 millimeter. If we use reinforcement with normal material, then the thickness requirement that we have found is 470 millimeter. There is a reduction of 25 millimeter. As our material having enhanced strength, so we have optimized this thing and we have found that thickness requirement is 420 millimeter. So 495 to 420, there is a reduction of 75 millimeter, and that is mainly in base course. The cost is per cubic meter is of that material is 3,000 rupees. Yes, surface, deep core. Now you see, after the numerical analysis, here the safe vertical strain for wrapping criteria is 0.007365, that is the safe. From numerical modeling with these layers, different layers, the strain, horizontal tensile strain, maximum vertical compressive strength at the top of the subgrade was found 0.007365, but allowable is 0.9999. So it is safe. Strain is less than the allowable. This case, after reduction of the thickness of say 75 millimeter, this case also we have found that 0.0008, where the allowable is 0.0009. So this material, after reduction of thickness of 75 millimeter means you can see more than 9 lakhs per kilometer. Saving. Now per kilometer actually. In India, major share of road network is rural road. More than 80%. More than 80%. Now 80,000 kilometer roads are there for rural. 80,000 kilometers. Now per kilometer there is a saving of say 9 lakhs. Okay, by using this material. This is not only laboratory scale study. I will show you the field scale study also. So this is the cost comparison. I have told you that though it is a cost neutral after laying, but there is no distress for next 5 years. And we give 18% cost as maintenance cost. 18%. So if it is a 70 lakhs is the 70 lakhs 18% is around 14 lakhs, 13 to 14 lakhs. That is the maintenance cost. So no distress you will find to next 5 years. Even in DL also. That has been visualized by us. Okay. Now the field trial, not only laboratory scale studies has been done. We did the field trial using after mass scale production in industry. I forgot to tell that we should acknowledge their contribution. In this project, with us, big industry, that is Gloucester Limited in Calcutta, was with us in this project, as well as WBSRDA, West Bengal Rural Infrastructure Development Agency, was there in this project. So they have also contributed a very big amount for construction of this field trial purposes. So what we developed, we have taken 2 roads in Purvasthali, one PMGSI roads, and it has been reported that every 6 months, even though whatever may be the construction procedure, every 7 months before we take over that road, was reported that that road was damaged due to repeated vehicle flying over the road, subgrade failure, and this road is more than 6 months, the embankment remains under water submerged. This area. So that is the main cause of damaging this road. In 6 months after construction, in 6 months that road was damaged. Everything. 6 months. This 3 section has been chosen. One is 0 to 200 millimeter, then 200 to 300 meter, and 300 to 500 meter. And whatever I have said, as per the laboratory studies and numerical modeling, same layer was considered there. You can see the thickness is 0 to 200 meters, and this our material used as subgrade 420 millimeter is total thickness, and conventional case 495 millimeter. There is a reduction of 75 millimeter. So this is the cross section. You can see the same cross section has been followed. DPR has been prepared, detailed project report has been prepared by us, and same cross section has been considered there. With here is the normal conventional road section for T6 traffic category. I told 0.3 to 0.6 MSA, and total thickness is 495 millimeter above the subgrade. Then in this case we have used only the geotextile, and total thickness is 470 millimeter, and this is the our material. The thickness is 420 millimeter. So before taking this road, before applying our technology in this road, we have found that this is the condition of this road, frequent racking failure was there, depression is there, distress was there. Now we started construction from the subgrade. So this is the subgrade preparation. Then our material has been laid over the road. Then subbase layer, water-bound macadam layer has been laid. Then also both sides also protected by crating, boulder crating, so that there should not be any slope failure, embankment failure. Then after construction, this package WB0509, this package, after construction, immediately after construction, you can see the condition of this road. Then after 12 months of construction, this road, no distress has been found over the road. Then after 18 months also, no distress. Now it is more than 2 years. 2 years. Okay, 2 years. More than 2 years. Yeah. So no distress has been till there is no distress has been. Still they have taken the photograph. No distress has been observed in the section 1 where our material has been used. We did lot of testing because to show the efficacy of your material, nobody will believe until unless you do the performance evaluation study, and it has to be witnessed by some faculty member of reputed institution. So for this case, after 18 months of playing, professors from IIT Bhubaneswar, professor from NIT Calicut and IIT Guwahati, 3 professors came along with National Rural Infrastructure Development Agency, their officers, and our industrial partners, and funding agency, all are there. Then in their presence, this performance evaluation has been carried out, and it has been found that during the performance evaluation study, it has been found that we did the plate load test to find out the modulus of subgrade reaction. The modulus of subgrade reaction on the groundwater layer, our material where our material has been laid, there is a modulus of subgrade reaction is 284, where normal density was laid 254, and conventional section with higher stiffness, his modulus of subgrade reaction is 200 MPa per meter. And modulus of subgrade reaction over subgrade is after, yes, this immediately after construction, after completion of construction, after 18 months, though there is a loss of strength, obviously the road will lose its strength, but still you can see there is 155 and here condensation 129 subgrades. Then we did also lightweight deflectometer test, LWT. So this is basically to measure the dynamic modulus. Dynamic modulus, you can consider as a resident modulus also. Somewhere it is called dynamic modulus, somewhere it is called resident modulus. So using LWT, quick test, no need to do the testing with undisturbed sample collecting from these layers and at the laboratory. Directly you can get the elastic value. So section 1, this is after 1 year of post construction, 205 and conventional section 136. So there is an improvement. After 1 year is 1.50 and 1.26 in conventional section. Then after 1.5 years also this has been done, and there is a also still there is a all cases you can see this where our development material has been used. There is a always showing the higher value. There is a modulus improvement factor is still higher. MIN. That material has the coating metal is the supplement as a reinforcing material. So this is another instrument that has been employed there, that is called GeoGauge. It gives the stiffness as well as elastic modulus. So in this case also this instrument also in all the time where we take read the field performance, always it has been showing that section 1 is giving the higher value. Okay. The two roads, values on two roads also the similar. All cases, the section 1 where our material has been used is always showing the higher stiffness, higher modulus, higher subgrades, all this. Even after 1 year, 1.5 year, even 12 months, 2 years, all the cases. So this is the first project, the first part. I am just conclude another two parts. Quickly I will tell. So there is a all the remarks has already been told to you. Only thing is that there is a reduction. Nano composite coated jute geotextile solution leads to an estimated reduction of 61.4 tons of CO2 emission per kilometer. This material, there is a reduction of carbon footprint of 61.4 ton per kilo. Now we can calculate for the total construction of this is a comparison with synthetic material. No, synthetic material is having the problem with polycoupling material. So this material, the comparison of this material and transportation, all these cases, is carbon footprint engineering. That has been possible. But in this case, it is a natural material, natural fiber-based material, so carbon footprint obviously is. But the reduction is 61.4. Now there is a video. I don't know whether it will Now you see this road, basically I told this area is submerged in water for more than 6 months in a year. So that's the problem of damages of the road. Because both the sides is submerged. And this is basically agricultural field in coastal area. potato, onion, they have grown in this area, and also jute. This area, now mass scale production has been done in the factory of Gloucester Limited. Before start of the work, layer by layer construction. 24 June, you can see the date, 24 June 2024. Now, yes, 2 years is over. I'm not showing you this. This is another project. I'm not showing you this one because we have limited time. Another project that I want to show you. Just you can see the installing this thing. The contact angle measurement of this space. Then numerical modeling using fluxes 3D for this material has also been used in railway track, high-speed railway. What is subgrade as well as subgrade and subpolished and polished. And but as per criteria of RDSO guidelines, RDSO standard RDSO guidelines, that is 004 RDSO guidelines. The minimum severe value requirement is 8%, but here in our case we have modified the chemical that has been used, and we have used another nanometer to increase the strength, more strength in delivery. Basically, the material we have used graphene oxide, graphene oxide, and it gives the severe value more than 8. And as these guidelines is there for regular RDSO 2007 G04. Minimum severe value is 8%. In our case, we found 8.8%. For the soil, severe value is 4.4. So more than double. And by utilizing material which has been found with we procured one instrument that is you can visit. Basically, yesterday we got a lot of training in Durgapur. After installation of all the equipment. So you can come. I will invite you. Institution here to NIT Durgapur for training purpose, and you can visit. Also, this is called cyclic loading test, dead load test. This equipment has been procured and this has been tested apart from chemical only, and there is, it has been found that by utilizing this material there is a reduction of reflection of 69%. 10 ms, 10 million standard axle, 10 million standard axle of loading of say axle load of 30 ton. This is the wheel axle load of wheel of locomotives is 30 ton. That has been taken with the frequency of 2.65 Hz was considered, that represents the speed of 160 km per hour. 160 km per hour. So there is a reduction of space of 73% and deflection of 69%. Now this I want to just tell you briefly this one. This another project has been taken from history also. This is how we can, this Raniganj coalfield is very close to us, Raniganj coalfield, and they have lot of problems. This mining. Major problem is that if you have visited any mines area, you will find that mainly it is for extraction of coal. But coal you will not find at the ground surface, just below ground surface. This is at different layers, it will be different layers sequentially, it remains below ground surface. So first layer you may find 60 meters below ground surface. Second layer may be of 100 meter depth. Third layer 150 meter depth. The thickness of this layer is around, somewhere I have seen 0.5 millimeter, only 5.5 meter thickness of same coal. Somewhere we have found 26 meter also, 26 meter, that there. But to extract that coal, 0.5 meter means the reserve is huge. Basically, thickness is 0.5 meter, but it extends more than kilometer. 10 kilometers. It's a huge reserve. And 26 means 6 meters, same means it is a huge quantity of coal. Okay. So that I have found in Monpur, the area, the thickness is 26 meters at some layer, not in the surface. Now the main problem is that to extract the coal, the upper layer has to be excavated. It is called open cast mining. Open cast. Upper layer is to be excavated. Now we cannot excavate it in a vertical. Then there is a chance of failure of slopes. It has to be sloping. That has to be designed properly. Now due to this excavation, huge quantity of material, mainly composed of sandstone shell, is comes out to get a coal layer at 60 meter depth for extraction. So 0.5 meter depth. This huge quantity of material is to be dumped in that area. It is called dumping of overburden. Now this dumping, the mines authority wants that they can dump with a steeper slope like say 34-35 degree angle, steeper slope angle. And height of the dump should be more, maybe 100 meters. Because they have to accommodate within a very short area, small area. Because as the 1 million ton of extraction of coal in Raniganj coalfield area, we have found 6 million ton of this material is generated, this waste material. 1 million ton, because stripping ratio is 6 to 7. 6 million ton means average density, if you take as 2, it will be more than 2. So 12 million cubic meter, 12 million cubic meter of this material will be generated. for per million ton of destruction of coal. And they generate more than 6 to 7 million ton. So around 80 million cubic meter of material has to be dumped in that area. And they have limited space. They cannot encroach the forest area. Very difficult to get the permission for land acquisition. So that is the biggest problem they are facing. So what they do, they dump it with slope, higher slope, more than the stipulated guidelines, higher height, more than this. And that's why, there are a lot of failure, but this failure is very catastrophic failure at Rajmahal area in Jharkhand. Last day of 2016, 31st December, there was a pit of 200 meter depth, and the dump material was there just beside the pit of more than 100 meter. And suddenly it collapsed. All the man, machineries, heavy equipment, all are burned, and that has not been recovered. Suddenly, a huge catastrophe. So after this Directorate General of Mine Safety, they have in 2017 they released the guidelines. It is called Coal Mine Regulations (CMR) regulations, and they have that has been revised in 2020 that there is some restriction has been given. We cannot increase the angle. The height should be limited. These are the things. But they are facing a problem that they don't have land. They cannot go steeper angle, more height. So where it will be done? So the thing is that we cannot do the mining. That is the problem. And underground mining is not economical. Huge cost involvement. There is also chances of failure, roof failure, and subsidence is another problem. Underground mining. It is reported every 2 days or 3 days there is a subsidence in Choria coal mines. There is a subsidence. So underground mining is not economical, and open cast mining there is lot of restriction, lot of regulation. So they are getting lot of problems. So this was taken up by us. How we can increase the slope angle and how we can accommodate more this material in the slope. So what we did, these are the same procedure. I am not coming to discussing this. Contact tank. These are that equipment we have purchased. This is UTM or geotextile. The cost is around 1.4 crore. I can show you there. Very pure. And these are we have this machine. We have seen direct set, large scale direct set test to find out the. These are the same thing. This is another machine I think we have seen, no? There in NIT Durgapur we have installed this. This is called geotechnical centrifuge. This machine basically, when I develop any material, so prototype testing is required. That we did for road construction, prototype testing. But in case of otherwise it is not possible to do the prototype testing because we have to wait for more than 2 years to see its efficacy. Now this machine is basically, it is having arm of 1 meter radius and diameter is 2 meter, and the bucket payload is 15 kg. It is rotated with a revolution of say 500 revolution per minute. 500 revolution per minute. Now, if we rotate 500 revolution per minute, it increases the G value, acceleration due to gravity, due to centrifugal force. Now, G value with 500 revolution, we can increase G value of 200 times. Now, see, I am standing here. Now, my weight is, I am giving pressure in the floor. Now say my weight is say 5 feet 8 inch. Okay. So rho G into H. Okay. Now rho G into H, my material will be same, low density. G H Now, if we can increase the G value, say 200 times, so I have the flexibility to reduce the H value of 200 times. I will impart same pressure in the ground because 200 by 200. Okay. Clear? So, if I take a slope of say 40 meter, if I increase the G value by putting there in the bucket have a limited height. So that 200, if you increase the G of 200 times, so it will be height of 20 centimeter only. 20 centimeter. That will represent 40 meter. So it will impart the same pressure with energy. Clear? So that advantage we have taken using this equipment. This is some calculation. You can see this RCF is called increase of G value. This RCF, okay, revolution per radius, revolution per minute, then these calculations are there. I am not coming. So it increases G value. This is the calculation. RCF equal to RTM, revolution per minute, and revolution per minute. So that will increase the G value. Now we can length, we can reduce, height, we can reduce. There is a dimensional analysis. So we did the testing to study the efficacy of this material. Here you can see this is unreinforced case. No reinforcement has been given, but height is 20 centimeter, slope angle has been maintained, say 36 degree. Angle 36 degree, 20 centimeter height. In the bucket, we are given the revolution of say, based on that calculation, you can get the, if we want to increase G value of 200 times, so that revolution is required. That calculation I have shown. So, this unreinforced case of a slope of representing the field of 40 meter with the G level of 200 times increment of G. So that has been seen that there is a failure. You can see there is a toe failure as well as crest failure, both the cases. Unreinforced case. Now we have tried to adopt our material as a reinforcing material at different layers. Okay, to study this efficacy with reduced strength. So you can see this is 150, 175, 200, all at increase of G value. Now, without reinforcement, the trace deformation is without zero. Zero means no reinforcement. Trace deformation is 14.6 millimeter in model, and in prototype it will represent 2 meter. 2 meter is a huge displacement in breast as well as slope face, 1.5 meter. So if we increase the reinforcement that has been tested in this using geotechnical centrifuge, that has been found there is a deflection has been completely arrested for different height of slopes. This is 150 means 30 meter slope. 20 into 150, 30 meter slope. 175 means 20 into that is 5 meter slope. And 200 means 40 meter height. So what you can see 30 meter slope, 4 reinforcement was found sufficient, here 5, here 6 reinforcement is sufficient to reduce the displacement. Okay. Then these are the factor of safety. As per the guidelines, minimum factor of safety should be 1.5. So we have tried with this, we have measured the factor of safety using numerical modeling, and with the increase of reinforcement, factor of safety value attained. Without reinforcement, it is less than 1.5. After introduction of reinforcement, it is more than 1.5. And this paper has been published. You can see all the papers already. Lot of paper has been published. This paper has been published in 2025 Journal of Art, System and Science. Another one, yes, this is the another modeling using rock science. So you can. Okay. So you can see there is a estimate of factor of safety for different height. Okay. Another paper has been published. This is in Clean Technology Environmental Policy in 2026. So the thing is that with the increase of height, now we can increase the height of using the reinforcement without any failure. Factor safety has been increased, no crest deformation, no slope based deformation, only increasing the reinforcement. So if we increase, we can increase the height of 40 meter instead of 30 meter earlier, and the angle also we can increase. So it has been found that in the same slope, with same base area, with the introduction of reinforcement, we can accommodate 24% more diet waste material in the same base area, and that will be highly acceptable to miner. They want this thing because no failure, there will be violation in that case, there will be chances of closure of mines by DGMS, no failure, more height, more angle, more accommodation of this waste material. In this 25% more is really huge quantity. Now we are trying to make it 60 meter.
The geotextile.
Yeah, I am saying. Yes, I understand here. So there is also carbon footprint reduction. You can, as I told you, this is natural fiber. There is a carbon sink basically. It is not emitting any carbon. It is carbon sink. That's why it has been shown as negative value. You can see negative value -3. Negative value. This is basically carbon because I will consider from plantation to production. Plantation, if you are also consider, so that is absorb also carbon dioxide. So that's why there is a carbon sink. Cost also, that material we have developed, the cost is 157 per square meter, and the synthetic part is as per CPWD schedule of rates 205. So there is a cost effective of this material, as well as the benefit is huge. We should not compare with cost only. Huge benefit, no failure, and more height, more this thing, more waste material can be accommodated. Huge, 24% as I told, 1.56 million cubic meter to 1.96 million cubic meter. For a height of 40 meter, the same base area. We need not to extend our base area. No land acquisition is required. Okay. This is the scheme, how it has been laid in this slope. This is laid in different layers. So this you can see for a height of 30 meter, minimum exposed width of each bench here test is 20 meter, angle of slope is 37.5 degree, and number is 5, 1, 2, 3, 4, 5, and this is extended within the slope of 15 meter. 15 meter. And over this, and spacing is 7 meter from top. And foundation should be strong foundation, should be made of sandstone because it will generate huge pressure. All cases. These are the, after this, what we did, we have tried to grow vegetation in the slope. Initially, I tried to use vetiver. Vetiver, the main advantage of vetiver is that, you know, it is in root length is more than shoot length. As root length is more, it will give more anchoring of the soil or the slope material, and it stays laterally, this root laterally. So more anchorage of this material is there. Okay, if you use better. But the problem is there to basically students are working. We cannot allow our students to go to the slopes and do for plantation purpose. So that's why now I am discussing with one scientist in CMRI. So this plantation can be done remotely. So he has developed one technology with some vehicle, small vehicle that can go and that can climb in the slope and that can go. Steep slope, 37 meters, steep slope, and a loose material basically. This material is not, chances of failure obviously there, so you cannot allow.
Geotextile.
Geotextile one by one, I am showing
How
you.
is it?
I am showing you. We did the physical study in one mine, Gangadam Chapel. Okay, so what we did, instead of hardy bark, we have used grass seeds that has been thrown in the slopes. Now it has been grown to the surface. Okay. So field trial, again, nobody can accept your work unless they do the field trial. Laboratory scale study, okay. Initial purpose, proof of concept, it is okay. To develop proof of concept. But nowadays, you know, all the funding agencies, they are asking for one thing, industrial collaboration, and not the collaboration with kind support. Cash support is required nowadays. Industry should give cash, say 20% of the total project value. And secondly, it should be the TRI level, technology readiness level, should be of around, you should reach around minimum 5. Okay. The proof of concept is laboratory scale is proof. So this is basically we have reached to proof of TRI 7. So these mines, Gangadam Chowk and Badulia mines in Parasul, Birbhum district of PDCL, that West Bengal PDCL, Power Development Corporation. So this is the slopes, basically. Now how it has been laid, this is, you can see one by one, I am showing the first layer. So there are 5 layers. That's only 5 layers are being present. So first layer, this is the surface preparation, one, then level surface, then the laid. So first layer means at 1 meter above, surface was leveled, then this has been laid, the material, then it has been overlapped with 2 rolls, then laying was done, then another dumping was done for this. Then another 5 meter was reached, then next layer, second layer, similar procedure, same procedure. Then third layer, fourth layer and fifth layer has been completed. So after this layer, we are now doing the monitoring. So it is more than 6 months is over. Now 1 month it is passing 1 monsoon season. Let's see. But the report is very satisfactory. I have seen that most of the OB slopes, we did lot of consultancy work with mine, that there is a tensile crack at the top. Crack develops. It is a loose material, grounded material, so cracks develop. You will find at top, if you go to DPL mines, Transdamotar mines, you will find that there is a cracks, wide crack. You will be in fear that whether I will travel on this surface or not, because there is many times it can subside. Deep crack as there. So all mines is a usual phenomenon of crack surface develops at the top. In this case, surprisingly, after 5 months of laying, no cracks has been developed. No crack has been found at the surface. Minimum time is required to consolidate this material is, I am considering, 2 years. If you can sustain for 2 years, then nothing will happen. Slope will not fail. Because vegetation will grow, it will be stabilized, it will pass through monsoon season, water pressure will develop, whatever the instability problem, all will be eradicated. No failure. Failure occurs initial time. After dumping of this material, initial time. Maximum failure occurs or overloading. Okay. So after 5 months, more than 6 months, I think is over. February, February, March, April, May, June. Yes. No, July. No, 7 months. No, nothing has been found. Okay. And then slope monitoring has been done, means we have inserted some pegs made of bamboo pegs over the press and the toe to monitor. We will measure the level, only RL will measure whether there is any difference in the benchmark. RL is measured, reduced level, whether any subsidence or nothing is happening or not. So till now it has, yes, this is, you can see, this February we have measured RL test, then March, then April. No significant. Red color is basically there some deviation is there, but it is not significant. You can see 89,871 and 89,865. More than less than a millimeter. So no deviation was found with this. Yes. This is only I have two slides. We'll finish.
So what is the standard length of this geotextile available? 15 meter?
Standard 100 meter.
100 meter.
Wide is you can make it around 5 meter. Width. It can roll can be of 100 meter. Even more also. Because until you cut it.
Sir, you told that failure can occur during the initial consolidation. And suppose if failure occurs, then can there be some remedies to
Remedies means failure occurs.
further?
Failure occurs means you have to
So failure
reshape the slope geometry. Only option. You have to provide more bench. Okay. But you have to reduce the load. More bench. Here I have not provided any bench, intermediate bench. This is a slope, continuous. You can 2-3 benches you can provide. But the thing is that overall slope angle will reduce. Overall angle. This angle you are providing the bench. Then again here, this point and this point you do. Then another bench this from here. So you will find ultimately you will find, and you are aiming to provide more than 37 degree. Ultimately you will reach to say 80 degree. So less material.
Sir, is there any maximum height that has been standardized by the pole authorities at
30 meter.
30 meter? And the slope angle?
37 angular repose, 37.5 angular repose. But scientific design, if you do the numerical modeling, then you will find that you cannot give more than 32. More than 32 degree without any reinforcement.
This is the maximum limit laid down by the pole authority.
That is angular repose of ground.
Angular repose.
Of ground limit. That is the response.
After the pole is then it is covered that soil or dump.
That is a fly ash, so mixed with sand. Sand is again now a precious material nowadays.
This dump is not disturbed. This dump.
Dump.
It is not even
Oh,
back.
after complete recovery, then internal dumping is done. Internal dumping.
No, this dump already created. Is it the mine?
Yes. After internal dumping, this material after extraction of, say, there are different layers. R1, R2, R1 is bottom layer. R1, R2, R3, R4, R5, R6, R7, R8, like that. So after extraction of all these layers, they can be dumped, and you will reach more than 300 meter below ground level. So immediately it cannot be done. Internal dumping can be done. Some places in mine authority, if there is a fault area, means there is a weak zone, shear zone, that is considered bounded. So they do not progress further. So in that case, that is called bounded, then internal dumping can be started from there. But still, huge material, very difficult to place that material in their area. So this is my last one. There is another project. I am not the PI for this project. Professor Minal Kanti Mandol of Chemical Engineering Department is PI. I am co-PI. But idea, proof of concepts were developed by me. We have taken the project to different names. This is basically, I have found in different industrial places. I acted as a nodal officer for that is grossly polluting industries, GPE, grossly polluting industries, appointed by CBCB, grossly polluting industries, their discharge of wastewater. in the river, in Ganga and Jamuna. So we did lot of auditing, you can see, in different industry around the side of river Ganga. So we have found that in association with West Bengal Pollution Control Board, but we have found that most of the cases, big industry, I should not take in their name, they have their well established effluent treatment plant, ETP, but they are bypassing the ETP and they are discharging directly their wastewater through some bypass drain. Pollution Control Board, every month they visit their places, but it has not been caught among the agent. But when we visited, then we found that there is a bypass drain. Most of the industry are found. So I told that no, you cannot keep bypass drain. You have to run ETP. Otherwise, how can you can discharge the wastewater, industrial wastewater directly in the river? So they are saying that do not write anything in our system will be closed. So but I have to immediately take the photograph, and immediately there is a mobile app that is connected with CPC. So immediately I have to do. So these are the things. But the thing is that I thought that why they are doing so? Because they are, if we can stop running ETP, then they can maximize their profit. Because the cost of running ETP is also high. So I talked with Pollution Control Board officer and discussed with them. If you can make a system that low cost and is a cluster base, more industry can generate their wastewater, they can directly discharge in the channel, and that should pass through a system, low cost system, where no skilled labor is required, no manpower, that skilled manpower is required, that can be done. So NIRI has developed in Nagpur one technology that is called constructed wetland, NIRI. So established system. So constructed wetland means it will arrest the pollution, that can arrest, and that can be passed through this wetland. Now, when I have seen their papers, I told my students, you know, Obisek worked lot on this, and he has more than 9 ASC papers that is published in this topic. And I have seen, I visited China also at that time as a BRICS coordinator. So I have seen there that they are also utilizing this technology, wetland technology for decontaminating the water. So we have tried, we make a cottage that is called this normal jute is having, the bond is basically, you know, it is having functional group of OH, hydroxyl for example, and it is having, when it comes in contact with water, so it creates the pi-pi bond. Sometimes it polyaromatic HH bond, quick bond, covalent bond, that they, when it comes in contact with this material. So, but it is having good absorption capacity. But the thing is that it degrades. So we have optimized with some solution that degradability can be reduced and it can use as a cottage. So that has been the work has been done. Now we have already discussed, already they came to us, we are waiting for funding, the rest of the funding. We will develop the system at NIT Durgapur for field scale, the wastewater treatment. Okay. Then it can be developed in NIT Durgapur, then we will invite the industries.
Waste will be in one.
No, wastewater pass through this system.
Water will
Pass through this system, and we will see its efficacy. Field lab scale, we have found very satisfactory results. Just I am showing you. These are generally you will not find that it has been tested or in pollution by pollution control board or any external agency. These parameters they test pH, BOD, COD, oil, gas, TDS, TSS. Plus these antibiotics nobody tests with pollution control board until a very good research project is there with pollution control board. CPCB do not do this testing. Polyaromatic hydrocarbon, but this is there. I have seen. We had a project with the Russia and China. They came, the scientists from Russia and China. They came here. We tested Damodar River. We have found tetracycline, doxycycline. These type of antibiotics is there in Damodar River. So this system can address polyaromatic hydrocarbon, antibiotics, 92 to 98%, pesticides, heavy metals. That has been tested in laboratory. Now we want to, everything is ready. Only thing, as soon as we receive the fund, 32 lakhs is pending, we will start development of product. So within 1 year you can see NIT Durgapur that this system is also there. Whether it will down or not, that I don't know, but we will see. Funding is there. First, and this is the last slide. This can also be used, but it has not been done by me. This is another opportunity that can be done. This is another big problem we are facing, riverbank erosion. That can also be done. That I know, but I don't have to go for it. Okay. Thank you very much. If you have any question, you can. Already I have taken question during my presentation. Still,
The session is open for questionnaires, so if you want to ask any question, ask.
Geotextiles, you told that we are using in road. It is without any, it will be, it would be in functional mode up to 5 years, right? Then
yes.
After 5 years or during this 5 years, what can be the maintenance work that can be done on?
Well, main thing is that within 5 years, that I have seen no distress. So 2 years is over. That way you can see the date. June 2024, 2008, now 2026. No distress is there. And we are expecting that we have checked the severe time, separate severe. That I forgot to tell. So this portion where what material has been used, no, the subgrade severe has been increased to 13%. The mechanism is not known. 5% was there initially. Now it becomes, that has been tested with that dynamic dissipate, dynamic bond penetration test, dissipate. So that has been tested and severe value has increased of 13%. I have not reported because we don't have the mechanism why it has been increased. So severe value is increased. Chances of rotting is less. No rotting will be this person. That's why no distress has been found till now. Even that road, as I told you, this road, this onion, potato, and other things are grown. Then sand also from the river Balighat. Sand is also flying, sand carrying vehicles. It's heavy duty. It is designed for the 15 ton. 10 and plus 5, front rear axle should take 10 ton and front axle should take 5 ton, 15 ton. But the vehicle is flying over this, if you could do the axle load, you will find more than 40 ton vehicle is flying over. Note that. Other two sections damages are found. This rotting has been found. Conventional section, so thickness is more, but rotting I have seen, distress is there. But this has been there. But this portion, nothing. So we are expecting that it will last for 5 years. And the thing is that maximum again, maximum is subsidence occur in the initial fluid. When vehicle is moving, there is a chances of compaction or the consolidation of this. So after this will be fully consolidated. So 5 years is an enormous time, big time for consolidation. And this helps also consolidation, this material. When it degrades, no, it will not last for more than up to 5 years. It may last for 3 years. I don't know also. Laboratory scale we have seen 3 years no times loss. But I feel how it will behave. Another thing I don't tell, if it is laid below 400 millimeter, no, from the surface, below 400 millimeter, in laboratory scale study, it lasts more. So NH, it will work better compared to rural. Rural load thickness is less. NH thickness is more because of different layers. So NH, maybe some anaerobic condition develop and the microorganism do not have that much of energy under anaerobic condition. That may be one explanation, I don't know.
So it can be durable up to, I suppose, 10 to 12 years?
That I don't know, but I am saying 3 years. 3 years is okay, sufficient. After 3 years, consolidation will not occur. There is no chance of any rotting.
So suppose its durability is up to 5 years, say. Then after 5 years, what can be done on it to increase its durability? That means we have to.
What is the need of increasing? I mean, because the road will remain the same, good condition. No? What is the need of increasing durability? Durability means again we have to conventional road. The rehabilitation is done. How it is done? The scrapping of this layer, then relaying.
Sir, what
There is no need basically. That I think.
What raw material you are using for making graphene oxide?
Graphene oxide, basically that nowadays nano, that is nano, through ball mill we have made in nano material. Ball mill, planetary ball mill.
The raw material is gold or coke or?
No, graphene directly it has been purchased. Nano composition we have through ball mill and particle size analyzer, measure that.
But graphene is gold.
That is not used for rural roads. That is only used for when you have used in railway, high-speed railway track, this embankment. Because in that case, we need more tensile strength. That's why we have increased it. Because severe value should be more than 8 as per the ISO RDSO guidelines.
So what type of nanomaterial is used into other that coating?
Well, that is silicon dioxide, graphene oxide. But nanometer. This is nano range, 20, 30 nanometer. It was -9 meter.
So NIT has started using this?
Jute, not this material, because just I forgot to tell you, already BIS Group of Indian Standard will release the standard very soon. All the compliance has been compliance and comments have been given, submitted, addressed. So probably very soon standard will be released. Then we will request to make it schedule of rates, SOR. Unless it will be in SOR, no, because they cannot purchase, they cannot make this item. Because they have to make the PFQ and they cannot make the item. So it should come in SOR. Schedule of rates. So after when the standard, also patent, we have just received the comments from IPR, Indian Patent, IPA. So it will be, patent has been published, but it will be granted. Because we have received the comment, so we will comply with the chance of granting the patent.
Thank you very much, sir. But before concluding the session, I would just like to offer my sincere apology to Dr. Pal, because mistakenly I have addressed him as associate professor. He is currently serving as the head.
From my profile there.
Yes, sir. Yes, sir.
My mistake, I think
I have just printed it from the CD that I have received. So thank you very much once again. It was a wonderful discussion. Geotextile, geosynthetics. That we have learned so many things. We haven't learned about this thing before, but it was so much technical nitty-gritty that we have learned. So thank you very much, everybody. Participants are requested that after the lunch we are having article discussion session and hands-on session after the lunch. So please have your lunch. Thank you very much. Now a photo session. Please wait for a moment.